Assalamualaikum and hi guys. So we continue about factors influencing dormancy. Number one we have learned before. So we move on into the next point number 2 about mycostasis or fungi stasis. Okay, what's that? Unsterile soil is able to stop germination of fungal spores, and this condition is called mycostasis or fungi stasis. Fungi stasis is a microbial induced suppression of spore germination. Fungi stasis causes spores to remain quiet sand in soil or environment until nutrients become available. For example, spores often fail to germinate to topsoil. Why? Because their level of microbial activity is high, but they germinate in sterile soil and can be prevented in the soil has been recolonized by microorganisms and even single microorganisms. So bacteria or fungi will restore the suppression. This suggests that fungi stasis is caused by nutrient competition or by general microbial metabolite or both, but not by specific antibiotic or other inhibitors from particular microorganism. So nutrient deprivation is as the key cause the fungi stasis. Okay, next point is nutrient storage. Spore has nutrients stored in their vacuoles. For example, in the conidium of Penicillium, reserve food are kept as polyol. Germination can only occur when there is enough food. Dormant spores have low metabolic rates, and this is only enough to sustain life. Okay, next point, wall composition and shape of spores. Dormant spores are exposed to unfavorable conditions. Spherical spores give minimal surface exposed to environment. Melanin, the color, okay, which is a black pigment, is a component of most spores and not easily degraded by microorganisms. If they therefore give protection to infection by microorganisms and also penetrating power of the sun's rays. Okay, this is about dispersal of spores, how they disperse. Okay, so type of dispersal, there are two types. Number one, usage of energy. Number two, characteristic of spores. Okay, usage of energy, they are passive dispersal spores, no own energy. Use environment, active dispersal of spores, they use energy from fungi. Okay, characteristic of spores, of course, dry spores, they are dry. Okay, so slimy spores and wet spores. Okay. Okay, we take a look. Passive, easily wetted spores. This type of spores, their spore drop stock is about 50 micrometer to 1 millimeter long. Transported by insect, carried by rainwater. Can also transport dry and slimy spores. For example, Sprongia of Dictyostelium and Mucor. Okay, this is just an example for this type of spores. Okay, next, stalk spores, they have a stalk. Okay, so for example, Sporangium of Mucor and Cinemata of Gampium species. This is another example. Okay, for passive and easily wetted spores, for this is next type. Okay, this is for rain splash or drip splash or splash carp. Rain wet fungi and slime are diluted. Water droplets carry spores far away. Peridioles are specific name for splash carps and spore set in some fungi. Peridioles, which are birds, okay, nest-like, are found in Basidiomycetes. Spores can be transported 1 meter away throughout this method. Okay. So next one is rain splash drips. Okay, rain splash or drip splash or splash carp. Okay, look at here. This is the picture about this type of fungus. Okay, via air and water, earth stars release their spores in the same way as puffballs. Amongst the other puffball relative, the tough skin of Scleroderma species to expose the spores to wind and water, allowing the spores to be washed or blown away. So this is an example for this type of via air and water. For a star, your left hand side, and Scleroderma, your right hand side. Okay, via animal, they're dispersed by via animals. Example, the left one is truffle and stickhorn, your right hand side one. Okay, next, passive and dry spores. Dry spores dispersed from spore sac by mechanical action. For example, stream of air form when animal knocks and vegetation and small spores are released. When hot in air rises and cold air settles, hot air carry spores. Rain can also break spore sac and release spores. For example, phototaxis have spore sacs containing electors that change the changes in moisture and thereby further dispersing spores. This is a passive and dry spores. Okay, they are using electrostatic repulsion. There are different charges in fungi and leaves. The different charges are result of charges in moisture, changes in moisture and infrared rays. In charges are similar. For example, spores and their spore sac, they repel each other. Spores are then released. Okay, next one is active dispersal. They are very active. Okay, something like us. Some people, they are very active. So this one also dispersal actively for the spores. What's that? Called turgid cell break. Okay, what's that? When asci mature, ascospores are pushed out of asci. There is hydrostatic pressure in asci, and other spores are thrown a few millimeter away. This will depend on size of ascospores. For example, neurospora and etc. Okay, so this is under ascomycete. Some spores are released with a strong vibration, vibrate. Okay, for example, nagospora or deuteromycete and etc. Okay. Again, active dispersal number 2, their characteristic number 2 is change in cell shape. Okay, spores can be dispersed in shape as sac change quickly. Eospores of Puccinia are polyhedral in shape. They have several faces. Okay, so absorb water and become spherical. During the charge, the change force is produced and thrown spores out of sac. For example, spores of Puccinia. Okay, this is actually just a picture all about the fungus related to that I've mentioned before. 5 type spores. Spores type. Okay, I think you can read by yourself. Okay, it's very easy to understand. We take a look for budding. Okay, this is a mode of vegetative reproduction of yeast. Of course, as you can see from here, the mode is actually, for example, for your left hand side, multilateral budding, bipolar budding, unipolar budding, monopoly budding. Okay, uni means one, mono means also one. Binary fission, bud fission, budding from stalk, and etc. Description and representative yeast example for the yeast genera. I think you can read by yourself. This table is very easy to understand. Okay. This one also the same thing about Ascomycota. I think you can read by yourself. Okay, we move on into the budding process. This is quite important topic. Okay, budding process. Okay, as you can see from here, so yeast budding initiated when mother cells attain a critical cell size at a time coinciding with the onset of DNA synthesis, followed by localized weakening of the cell wall together in tension exerted by turgor pressure allow intrusion of cytoplasm in an area bounded by new cell wall material synthesized by enzyme, for example glucan and chitin synthesis. Chitin, a polymer of N-acetylglucosamine, forms a ring of junction between the mother cell and the bud. Okay, the chitin ring is actually will eventually form the characteristic bud scar after cell division. Once new daughter bud has initiated, cell surface with growth during the remainder of the cell division cycle is restricted to the bud. Okay, mother cell wall does not grow very much during budding. Mother and daughter bud contiguous during bud development. Once mitosis is complete and the bud nucleus and other organelles, for example mitochondria, have migrated into the bud, cytokinase ensures an acceptance is formed between mother and daughter. Okay, next one, next step for budding process. Of course, as you can see from your right hand side, a ring of protein called septin, okay, are involved in positioning cell division. These septin are encircle the neck between mother and daughter for the duration of the cell cycle. Okay, I think that's all about this topic. Thank you very much for your attention. Thank you.